All right, so today we're going to be learning about structural formulas, and structural formulas are going to show us how elements are bonded together and how they form compounds. So before we've learned about how to take two elements or more and bring them together to create a compound. So example of a compound would be like H2O. But that doesn't, it just gives us a list of how many of each atom we have. That's like our materials list. Now it's going to be like we're going to draw the blueprint and we're going to know which atoms are actually bonded to each individual other atom. So in H2O, are the two H's bonded together, or is an H bonded to an O? Okay, so that's what we're going to be doing for structural formulas. So you can see I have some examples here. Actually, this one on the bottom here is H2O. So you can see there are two H's, 1, 2, and there's one oxygen. All right, so you can see the difference. It starts to show the way that the structure is formed. It does not show you the exact shape. So something to remember, that these are not 2 and 3D molecules. We're not doing any sort of geometry or shape yet. That's going to be our next step. All right. So this example right here is CH4, and you'll notice it's not one C with a line of H's. Okay, the C's in the center, and usually the first element is in the center. Okay, and then the H's are around it. So we're going to learn how to know that. This one right here is NF3, and you'll notice that we've seen some dashes right here. This is going to be a bond. It represents 2 electrons. And then we've got electrons here that are lone pairs of electrons. We're going to look at our Lewis dot diagrams, and they're going to help show us why this looks like that. Okay, so things to know is that a dash, it represents a bond, so it's 2 electrons. And the way we're going to start drawing these is we're going to start with the Lewis structure of the central atom. That's going to be the one that comes first, okay, the one with the smallest electronegativity. All right. So for example, NF3, you start with drawing the N Lewis dot structure, 1, 2, 3, 4, 5, because it's in group 5. So you can see how this will become a bond with an F, this will become a bond with an F, and this will become a bond with an F. Okay, so you get it to look something like this. We're going to do this next. What you'll notice is that there's going to be a pattern. If you look at the Lewis structures, and then with the number of bonds the element is able to make, it's based on the number of unpaired electrons with its Lewis structure. So a way of remembering this is H-func 1, 2, 3, 4, okay, or hunc 1, 2, 3, 4. Hydrogen and the entire group 7, which F is at the start of, at the top of, are going to behave the exact same way. So all of group 7 plus hydrogen will have one unpaired electron. That means it's going to make one bond. So this is going to be the number of bonds right here, these numbers 1, 2, 3, 4, that it typically makes. Okay. Group 6, which oxygen is the start of, is going to have the same structure here. 6 valence electrons. So when you spread them out, 2 are going to be bonded pairs. Okay, this is going to be a lone pair of electrons. Okay. Lone pair of electrons, and then 2 are actually going to be needing to make a bond. So a bond is going to be made here and here, 2 spots. N, 5 valence electrons, 1, 2, 3, 4, 5. It can make 3 bonds. 4, group 4 has 4 valence electrons. It'll make 4 bonds, okay? So for example, we're going to start with these ones. So I'm going to start with N, and I know N is in group 5, so it's going to have 5 valence electrons. So I draw my Lewis structure, all right, and then I'm going to switch ink colors so you can see the H's. Okay, my H's each, if I just draw an H over here, I know it's going to bring 1 electron to share. Remember, these are all covalent. Okay, so I'm going to turn this into a bond right here by letting them share. 1H. This is going to get turned into a bond, letting this guy share. This is going to get turned into a bond, letting that guy share. So if I redraw this, it'll be N, H. It's going to make 3 bonds, which we knew because we looked over at our hunc 1, 2, 3, 4, 3 number of bonds it's going to make. All right, and then I can't forget to draw this lone pair of electrons. That's very important. Okay, so let's try it based on the number of bonds for this one. So we've got OCl2. So O comes first, and it's the least electronegative, so we're going to draw it first. So I've got oxygen, and I'm going to put 2 bonds, because oxygen can make 2 bonds. So I'll put a Cl here, and then I'll put a Cl here. Okay? To know how many other electrons I need to put on, what I'm going to do is say oxygen is group 6, so it has 6 valence electrons. Chlorine is group 7, so each chlorine has 7 valence electrons. So 6 plus 7 plus 7, 6 plus 14 is 20 total electrons that I need to represent. I have 2, 4. So I'm going to start by filling my outside electrons, and then I'll fill my central atom. So 2, 4, 6, 8, 10, 12, 14, 16, 18, finish up on the central atom, 20, finish up on that O, okay? So you always are going to add your electrons in pairs. Let's try CH3F the same way, okay? So we're going to start with carbon as your central atom. It can make 4 bonds, so I put my carbon in there. I'm going to put an H for 3 of them. And then my 4th one is going to become an F. Okay, and now I'm going to start making my electrons, but I need to know how many I want in total. So C is 4 valence electrons. Each H is 1, so that'll be 3, plus 7 from the fluorine. So that'll be a total of 14 valence electrons that I'm looking for. How many do I already have? 2, 4, 6, 8. Now when I'm placing my remaining electrons, I need to remember hydrogen is satisfied when it has 2 around it. So all these hydrogens are already satisfied. So I've got 2, 4, 6, 8. It'll go 10, 12, 14. And now you can see the F, the fluorine, is also fully satisfied. Carbon is fully satisfied. They each have 8 valence electrons. And that's called the octet rule. Okay, so the octet rule says that atoms are satisfied by having 8 valence electrons. Okay? And your exception are hydrogen and helium. They only need 2. And helium, for this intent and purposes, it's not really going to bond, so it doesn't really matter. Really, hydrogen is your huge exception, and it only needs 2 valence electrons. Alright, so what I would like you to do is I would like you to take a few minutes and I would like you to try 2 of these. I'm going to help you out by telling you nitrogen is 5 valence electrons, hydrogen's 1, Cl is 7. Okay, remember your group, your valence electrons are your group number. Okay, and you can try the second one totally on your own. So valence electrons equals group number. All right, good luck.